Hello friends, in this video we are going to talk about something called banking of roads. Okay, now banking of roads, it is an application of circular motion. Let us imagine a car taking a circular turn on a curved horizontal road. Okay, so if this is the road, okay, maybe like this, and this car is over here and it is taking this circular turn. Okay, radius of this circle, okay, up to the center of mass of car, okay, let us imagine that it is r, okay, and v is the velocity of the car. Okay, mass of car may be taken as m, we have radius of circle as r, correct. Now we know that for circular motion to be possible, there has to be centripetal acceleration. So something that pulls the car towards the center of the road, and so that circular motion is possible. So we would definitely need some centripetal acceleration, and we know that centripetal acceleration is given by v square upon r, correct. So now if acceleration is v square upon r, then centripetal force, okay, FCP I call it, that would be equal to mass into acceleration. So it would be m into v square upon r. That is the centripetal force. But then this centripetal force has to be provided by something, right? So in this case, what does it, what provides this necessary centripetal force, right? So over here, the friction between the tires and the road, okay, which acts in this direction, okay, this force of friction that provides the necessary centripetal force. Now we know that if we have a mass here, okay, mass m, so then weight is mg, normal force is n, and if this is the applied force F, then friction acts in opposite direction, and then magnitude of this frictional force, okay, here it is equal to mu times normal force, but then over here there is no force acting in the vertical direction apart from mg acting vertically downwards and normal force acting vertically upwards. So we can say that n, or normal force, is equal to mg. So this force of friction would be equal to mu times mg, and this mu is nothing but coefficient of static friction. Okay, now in this case, okay, in this case, mass of car is mg, mass of car is m, and weight is equal to mg, and normal force acts like this, and then here, even here, the force of friction would be equal to F equal to mu times mg. Now this force of friction has to provide the necessary centripetal force, isn't it? So we can equate frictional force with centripetal force. So I would write this as mv square upon r. Here the r should be capital because my radius of road I have taken as capital R over here, right? So so it's mv square upon r would be equal to mu times mg, correct. Now cancel this m on either side, and your v square would be equal to mu into r into g, or v is equal to root over mu r g. Now what does this expression tell us? This expression tells us that if coefficient of friction between the tires and the road surface, if it is mu, radius of curve that the car is taking, that is r, and g is the acceleration of free fall. Okay, so the velocity with which this car can safely take this turn without skidding, okay, without skidding off the road, okay, that is given by this. Okay, so in this case, for the car to take to be able to take that circular turn, force of friction is playing an important role. Okay, so the friction between the tires and the road surface, okay, that would be that has to be within limits, isn't it? So if the radius is greater and mu is small, has got some small value, then obviously my velocity would be smaller. Okay, if that car exceeds that velocity, then there are chances of the car skidding off the road. Okay, so this V gives you the safe speed with which the car can take the turn. Now there is a catch here. Okay, because the safety of the car, at that speed or on that road, okay, it depends totally on the coefficient of friction, isn't it? In normal conditions, that may be all right. What about monsoon? Okay, where when the road is wet, the value of mu, the coefficient of friction, that is going to reduce. Okay, in different conditions, this mu is going to be different, and then this would not be really a dependable proposition, isn't it? So there has to be something more. Apart from that, when you are depending on this force of friction for safety of taking turn, then you are compromising on the wear and tear of the tires. Okay, and again, that would not be really a good thing. So what do we do? For this, they bank the road. It is called banking of the road. Let us see what it is. So banking of road is basically raising the outer edge of the road over the inner edge through some angle, and then angle through which we do this, okay, that is called banking angle. So if I have a banked road like this, okay, and this is my horizontal, this angle is theta, which they call angle of banking. My car is over here. Now I am going to have only a rectangle here. You just have to take it as a car. Okay, car of mass, let us say m, right? My center of this curve, okay, it will be somewhere here. Okay, I'm not going into much details, but then that radius of the curved road is r. Okay, up to here, up to the center of mass of the car. Okay, now we have to think about what forces are going to act. Okay, the weight acts vertically downwards, so it will act like this. Okay, this is mg, correct? Normal force given by the road would be perpendicular to the road. Okay, so this is normal force N. Okay, now other forces, we have only weight and normal force and force of friction in this direction, right? Now the other forces, I want to resolve these forces, and I am going to do with different color. See, this angle is theta. Okay, then angle made by the normal force with the vertical, this angle will be also theta, correct? I am going to resolve this normal force along y-axis and along x-axis. So I have this as my n cos theta, and then horizontal component of normal force would be n sin theta, correct? Now the force of friction again, okay, force of friction has to be again resolved into two components. This x component would be f cos theta, and its y component, the vertical component, would be f sin theta, right? That's it. Is it not simple? Weight acting vertically downwards, normal force acting perpendicular to the road surface, force of friction acting along the slope. Okay, and my centripetal force over here, okay, that would be equal to mv V square over R, and that would be over here. Now let us add the vertical forces and horizontal forces. So if I do suppose sigma fx equal to 0, so n cos theta minus f sin theta, that will have to be equal to mg, isn't it? So mg is equal to n cos theta minus f sin theta. Okay, that is mg. And what about horizontal forces? Now f cos theta plus n sin theta, both are pointing towards left. I'll just write this properly. I would say mg here, because that equal to sign has to come in the same line. Okay, so so mv square upon r, that is equal to n sin theta plus f cos theta. Okay, now what about force of friction? My force of friction F, small f, is equal to mu times normal force. It is mu times normal force. Okay, force of friction is always equal to coefficient of friction times the normal force. Okay, I'll substitute that F is equal to mu n over here. Okay, so my mg, or then maybe what I'll do is I'll take ratio of 2 with 1. Correct. So I'll say 2 upon 1 gives me mv square upon r divided by mg is equal to n sin theta plus f cos theta. So now f I'm going to write mu n, so I'll just change it over here. So mu times n cos theta upon n cos theta minus f sin theta. So n cos theta minus mu n sin theta. Now you can see here n and n. I can cancel this n's in the numerator and the denominator. So, and of course this mass on the left hand side is going to get cancelled. So v square upon rg would be equal to sin theta plus mu cos theta upon cos theta minus mu sin theta. Okay, let us simplify even more, because I don't want to calculate sin theta and cos theta and do the multiplication. So what is the simplest way to do that? Okay, I would divide the numerator and the denominator by cos theta. So then this would become mu cos theta upon cos theta is equal to mu plus sin theta upon cos theta is tan theta divided by cos theta upon cos theta is 1 minus mu sin theta upon cos theta would be mu tan theta. Correct? So now you see here v square over rg is equal to this much. Okay, so that gives me v is equal to root over rg multiplied by mu plus tan theta upon 1 minus mu tan theta. Now we really need to understand what is the gain out of the whole exercise. What we did is we raised the outer edge of the road over the inner edge, but then are we gaining anything? Yeah, We need to understand that. Now here, if you look at this expression, okay, suppose my angle of banking is 0. Okay, so that means if theta is equal to 0, so if theta equal to 0, then what happens? Tan 0 is 0 and 1 minus mu tan 0, which is 0. So, my denominator will become 1. Okay, numerator will become only mu. Okay, so my V would be equal to root over mu rg, and that is what we got some time back, right? For a car taking a turn on a curved horizontal road. Okay, this was the expression. But what if my mu becomes 0? Okay, the road is banked, okay, and the coefficient of friction becomes 0. That means the road is completely slippery. Okay, in that case what happens? So my V would be equal to root over rg. Now here, now mu is 0, but my tan theta is there. Okay, so mu becomes 0, so denominator again becomes 1 and numerator becomes only tan theta. So it would be rg tan theta, correct? So the role of mu over here, the role of coefficient of friction in the first case, that is taken up by tan theta, right? You can try this. You can try substituting for maybe you can take these values. Mu is equal to 0.25 and theta is equal to, let us say, 5 degree. If you substitute and the radius of the curved road, maybe that may be 250 meter. Try doing this. Try to find out the velocity by substituting mu, theta and r in this expression. You will get certain velocity, okay, certain safe velocity with which the car can be, the car can go on that road. Okay. After that, put only mu, put theta equal to 0, you would get this value. Okay, and if you only have to rely on tan theta, you will get some value. Okay, you will definitely find that when you have mu as well as tan theta in place, okay, the safe speed of the car increases, and that is the beauty of banking off roads. Okay, you will be getting a few examples or exercises to solve in the description. Thank you so much.